Question 28. A company wants to determine whether its consumer product ratings have changed from last year to this year. The table below shows the company's product ratings from 8 consumer for last year and this year. Is there enough evidence at alpha is 0.05? Is there enough evidence to conclude that the ratings have changed? Assume the samples are random and dependent, and the population is normally distributed. So we've got a paired samples thing here, right? So consumer 1, we have their rating last year and this year. They think it's worse this year than last year. Consumer 2 thinks it's better, went from 6 to 7. Consumer 3 thinks it's worse, from 4 to 2, and so on. Right? And so we're going to identify the claim and we're going to state the hypotheses. So the claim, we want to know, is there enough evidence to conclude the ratings have changed? Right? So have they changed? That's the claim. So either the mean difference is 0, in which case they haven't changed, or the mean difference is not 0, they have changed. So 0 versus not 0, that's this one, E. F is also a 0 versus not 0, but it's backwards, right? The null hypothesis can't have a not equal sign. That can only be the alternative. The null hypothesis has to have the equal sign. So E is our hypotheses. Now the critical values we're going to get from the calculator, we're going to go distribution T inverse T. The area, because it's equals versus not equals, that's a two-tailed test. We can be greater than or less than. So we're going to do 0.05, that's the alpha, divided by 2. And then the degrees of freedom is going to be 8 minus 1, so 7. So there's 8 people, 8 consumers. So n minus 1 is the degrees of freedom. And so our critical values are positive and negative 2.365. Right, we have 2 critical values, again, because it's a two-tailed test. We got equals, not equals. We have a lower and an upper critical value. And so we're going to reject the null hypothesis when we are in this region, right? Less than the negative or greater than the positive. Okay, so now we have to calculate all this stuff, but I don't think we need to do it by hand because we have the calculator to do it for us. So we're going to type this stuff in the calculator. So last year is going to go in list 1. This year is going to go in list 2. So we got 5, 6, 4, 6, 8, 8, 7, 8 in list 1. And then in list 2, we have 4, 7, 2, 5, 4, 4, 8, 6. And so we're going to go test T. It's not here. There's no paired samples, right? 2 sample, that's an independent samples test. That's not what we want. We don't want that. What we actually have to do is we have to find the differences here. Right? So we're going to subtract. Now they want D bar. And so the order of our subtraction is very important. If we do list 1 minus list 2, we'll get positive 1 for the first one. If we do list 2 minus list 1, we'll get negative 1 for the first one, right? And so we need to make sure we are paying attention to which way they want us to do the subtraction, and have they told us which way to do the subtraction? Because frequently the questions will just say which way to do it. So it doesn't say, as far as I can tell, reading it over, it doesn't say. Oh, no, it does say. There it is. I almost missed it. The ratings last year minus the ratings this year. So last year minus this year, list 1 minus list 2. That's the order we're doing it. Okay. So always just check the question carefully. It almost always will tell you which way to do the subtraction. So 5 minus 4 is 1. 6 minus 7 is negative 1. 4 minus 2 is 2. 6 minus 5 is 1. 8 minus 4 is 4. 8 minus 4 is 4. 7 minus 8 is negative 1. And 8 minus 6 is 2. All right, so list 3 is where our differences are. So now what we're going to do is we're going to go test T 1 sample, and we're going to put list. Where is our data? It's going to be in list 3. List 3 had our differences. And then the question was that difference equal or not equal to 0, right? So not equals, oops, go back, not equals 0 from list 3. We run that and we get everything we need here, right? The sample mean, the D bar is the X bar, that's 1.5. The SD is the SX, that's the 1.927. The T, the test statistic, is the 2.201. Do we reject or fail to reject the null hypothesis? Well, 2.201 is not greater than 2.365. So it's not quite in the rejection region. We fail to reject. We don't reject the null hypothesis. We do not have enough evidence. So at the 5% significance level, there is not enough evidence to support the claim that the product ratings have changed. Right, we got kind of close, right? 2.201 is close to 2.3 whatever, 2.365, but not quite enough evidence. And so that's question 28 with a paired samples test. Right, it's a little bit different than the other tests we've been used to, because we had to do some of the work by hand. We had to do subtraction by hand to get our list 3, which is our differences. And then we run a one sample test on the differences.